Hey, what's up, LH2? We're going to keep rolling with probability here, trying to find out the total number of outcomes, expand on that fundamental counting principle, talking about permutations. It's a special case. We're going to get into combinations tomorrow, which is another special case. So let's just take a look at see what permutation is. A permutation, mathematical technique that determines the number of possible arrangements in a set where order matters. Okay? We're going to focus on those words. Arranging objects, order matters. Okay? We're going to start out by looking at 3 books, and we're just going to arrange them on a shelf. How many different ways are there to do that? Well, here we go. We got a green book, a blue book, and a purple book. Now, if I took and I kept the green book first, and then put the purple book second, and then put the blue book third, is that a different order? You better believe it. Right? Green, blue, purple is different than green, purple, blue. Right? So how many different ways can we arrange this? Well, the way my brain would do this is start out with the possibilities of green first, and then purple, blue, purple, and then flip-flop. And then I would go to, hey, let's pick a different book first. Let's pick blue first, do green, purple, then blue, purple, green, and then likewise with green, purple, blue, purple. Or purple, green, blue, purple, blue, green. All right, so as you can see, there are 6 different ways to make this work. What happened if we added 3 more books to this? Right? That's going to stink big time. Right? If we added a red book, a orange book, and a black book, right? And we just use that idea of ordering the last 2, reordering the last 2 numbers, and then the green, and then that's not even taking into account reordering how many ways there are for if the blue book was the second, and then the purple book was second, and all that. So this is going to stink. So there's got to be a quicker way to do this, and lo and behold, using that fundamental counting principle is going to save us. Okay? Now, I'm going to leave the book options up here in the top left because I want to show us here. We're going to do what we did yesterday. We're going to make 6 blanks. How many books do we have to choose from right now? We have 6 possible books to choose from. Let's say we took and put the red book on the shelf first. Bam! Now we get to that second slot here. How many books are available for that second slot? Well, there's only 5 because the red book's already on the shelf. Let's say we pick the blue one. Now we have a choice of 4, 3, 2, 1, all the way down. You multiply all that stuff together in that calculator. 6 times 5 times 4 times 3 times 2 is 720. All right. Another way to write this is 6 factorial. All right. Factorial is how we would write that, and that's just saying start at 6. All right. Start at the number in front of the exclamation point and write out all the numbers that come before 6 and multiply them all together. So 10 factorial could be written as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. Oh gosh, I'm getting tired. Times 2 times 1, right? A long, annoying process. So there is a way in the calculator to calculate that stuff out, okay? I did it with 5 books. I saw that number 6 here. This is if we had 6 books. If it was 5 books, then we would just do 5 times 4 times 3 times 2 times 1. Okay? How many ways can 8 books be arranged on a bookshelf? All right? Well, that's going to be 8 factorial because order matters, right? We're arranging different ways. Bookshelf, 8 times 7 times 6 times 5, 4, 3, 2, 1. Multiply all that stuff out, and you get 40,320. Okay? Now here's a question. What if we have 8 books, but we only have enough space on the shelf for 3 of them? How many arrangements are possible then? Well, I'm going to go back up here. We have 3 spaces right here. Okay? We only have 3 spaces. We have 8 books to choose from. We pick one. Now we only have 7 books to choose from. Now we have 6. We pick one out, and then we run out of space. So we're only going to talk about 336 combinations if we're only taking 3 of those 8 books. Okay, this is what we would call a permutation. All right, 876. A way to look at that would be we have 8 objects to arrange, and we are going to pick 3 of them. That's another way to write it, another way to see it. I'm going to, in a little bit, talk about how we can use our graphing calculator to show us this, right? But I think in my head, the way this works out a little bit easier is if we have the spaces. So we have 10 books, 10 objects. We have 4 ways to put them, 4 spots to put them. So that's 10 times 9 times 8 times 7, which is 5,040. Okay, what happens, or what would this look like? 10p4. All right, we have 10 objects. Since order matters, we're going to pick, and then only 4 of them. We can put that in the calculator. Okay, the way this works is there's this lovely specific formula. I'm going to show you just this one time. N is the number of objects. So in the last case, we had 10 objects, 10 factorial. And then we're going to do 10 minus, and then we had a spot for 4 factorial. So then it was 10 factorial over 6 factorial. And then what we're going to do is we're going to use that concept of rational, we have fractions here. How do I simplify them down? We would cancel out. We would only go down to 6 factorial, right? I'm not going to do 6 times 5 times 4 times 3 times 2 times 1, because that's what this is going to have, and we have common factors. Cancel them all out. We're left with 10 times 9 times 8 times 7, which is exactly what we had over here. Okay, so we're not using that formula. It's this how all this math works out. But I think our thought process with this is going to make more sense to us in the long run. Right? If I was going to use this in the calculator, right? I want to type in 10p4 into the calculator. Depending on the operating system of your TI-84, you might have to type in the number 10 first. Okay? Then you're going to hit math. Arrow over to PROB, probability. And then select NPR. If you have a calculator with the operating system like me, a little bit newer one, you are going to have it look like this, where you can just arrow to the boxes and then put in 10 and then put in 4. If not, the older operating system, you would type in the 10 first, do math, probability, NPR, and then you would type in 4, hit enter, and you'll get 5,040. Okay? If you wanted to use Desmos, okay, I'm going to blank these out here quick. So, how do I get my screen back? What the heck is going on here, folks? All right, just type in there. Silly. All right, we're going to go to functions in that bottom right. Stats, so trig, stats, all this other stuff. We're going to pick NPR. We had 10 objects, comma, pick 4 of them, gives us the 5,040, which again, that's the same thing as us doing 10 times 9 times 8 times 7, which gives us 5,040. So either way, doesn't matter how you use that calculator, how you're doing the math. You can do it with a simple calculator on your phone without even having it being scientific for this stuff. But I'm just showing you, if you have those calculators or you're using them, might as well get your money's worth, right? All right, so here we go. Student government selects president, vice president, secretary, and treasurer. These can be kind of tricky ones because you might ask, does order matter? And you better believe it. Is president different than vice president? The answer is yes. So we have 10 people, or not 10 people, thinking of the last problem again. We have 6 people. We have 4 open slots, so we're picking 4 of them. So one way to think is 6, 5, 4, 3. Or in the calculator, you can do 6, math, arrow over to probability, select number 2, NPR, and then get 4, and you get, either way, 360. Okay, awards are given out at a costume party. They have 8 contestants. They're only giving out 3 awards. Does order matter? Heck yeah. Most creative is different than silliest, right? So this would be 8 times 7 times 6, which is 336. Or the other way to look at that would be we have 8, pick 3, which is going to give you 336 in the calculator either way. Okay? If you got this last one, life's all good here. All right, so we have 9 boys, 12 girls. We're going to arrange 4 boys, 3 girls, so it goes boy, girl, boy, girl, boy, girl in line. Create your slots. Focus on the boys first. It's going to be easier to focus on the boys first. 9, 8, 7, 6. Well, what did we really have? We had 9 total boys, and we were picking 4 of them. So that would be 9, 8, 7, 6, which is 3,024. All right. Well, now let's go with the girls. We had 12 girls to choose from, and we only have 3 spots. So we're going down, doing 12, pick 3. 12 times 11 times 10 is 1,320. Sorry, I wrote this wrong. I did the math right, though, unfortunately. This should be a 9, not a 12. I apologize, but I still did 9 times 8 times 7 times 6, got 3,024. Okay, and then the fundamental counting principle says, hey, let's take each option and we have a grand total of 3,991,680 different ways to line up. So, and that's if we just took 7 spots. So if you had a grand total of 21 kids in the class, how many different ways could your teacher line up the kids using boy-girl order? Holy cow, there's a ton of just grabbing 7. So your teacher not only has a lot on their plate on what they're going to teach you, how to teach you, but they have a lot of different ways just to order things up. Okay, so look for the homework. Again, answer keys. There isn't going to be a quiz this week. There will be a final quiz that'll have all probability next Thursday. Have a great and wonderful day.